Welcome to Merlin Circuit Technology, part of the Merlin PCB Group. During this film, we'll explain the basics of manufacturing a multi-layer printed circuit board, or PCB for short. During the quotation stage, the customer's data is checked against capability. After order acceptance, the contract review is undertaken, which checks data, drawings, assumptions, and laminate availability. The customer's data, either ODB++ or Gerber, will be automatically checked against our capability. If alterations are required, the customer will be contacted by EQ form. Customer's single circuit will be stepped up to fill the production panel, 24x18 or 18x16. The chemical solutions present in the production lines are regularly analysed to ensure they meet the stringent levels determined by the suppliers of the process. The laminate and prepreg specified on the route card is pulled from stock, checked for compliance and released to production. The batch codes are recorded on the build sheet, so material traceability to source can be maintained. The CAM image is transferred onto the circuit by laminating the inner layer material with UV-sensitive, photosensitive resist. The inner layers are auto-loaded onto the cleaning line, passing through a chemical etch, dryer, FOD removal and preheat, before having the dry film resist applied to the laminate using heat and pressure. The resist is then exposed to UV light in specific areas, which polymerizes or hardens the film to create the circuit image. The exposure can be achieved using either artwork and UV light or a direct imaging machine, which uses a laser to scan the CAM image onto the UV-sensitive resist. Outer layers are also printed in the same way, except that the outer image is reversed. This process is completed before the panels are run through the pattern plate line. The DES machine, standing for Develop, Etch, Strip. Firstly, the operator removes the protective mylar coating before loading into the developer section of the DES. This removes any resist that hasn't been exposed with UV light. The board then passes through the etch stage, which chemically removes the copper. Finally, the mask that has been UV cured and has stopped the etch from attacking the copper is removed in the stripping section of the line. The manufacturing data from the CAM is compared against the circuitry on the panel using the automated optical inspection machine. The panel is cleaned prior to scanning the layer. The AOI scans the circuit board and highlights any differences from the CAM data. Any discrepancies are checked by the operator and either repaired or discarded using the appropriate IPC rules. The panel is treated using a chemical etch which roughens the surface of the copper to aid adhesion, giving the copper a salmon pink appearance. The inner layer panels are then stacked up with prepreg, a glass fibre sheet impregnated with resin between the layer pairs, and copper foil placed on the outside of the stack in the required order shown on the build sheet. Pressure and heat is applied under a vacuum at specific parameters, which allows the resin in the prepreg to flow and bonds the layers together. At this stage, we drill the holes that will form the electrical connections between the layers of the PCB. The locations are determined by the customer's design to fit specific components. Drilled hole sizes are usually 100 micrometers larger than the finished hole sizes to allow for the copper plating process. The drill machine can detect when the drill piece has a broken or chipped drill, and when the drill becomes blunt, can automatically change to a new drill. Panels can be drilled up to 4 high depending on board thickness, drill size, and copper content. After this stage, a thin coating of copper is chemically deposited on all the exposed surfaces of the panel, including the hole walls. This creates a metallic base for electroplating copper into the holes and onto the surface. The customer may request that some or all of the via holes are to be plugged with resin and capped over with copper, IPC 4761 Type 7. The ITC via fill machine has a set of vacuum heads which create a localized vacuum. The epoxy resin is then pulled into the vias due to a pressure difference. This ensures that through and blind vias can be filled 100% with no voiding. The copper plating is deposited electrolytically on areas without resist and within the vias to create connections between the inner layers. The panel is placed in the plating solution and acts as the cathode side of the plating cell, attracting the copper when an electrical current is applied. Tin is then applied, acting as an etch resist. The SES line, or strip etch strip line, firstly removes the plating resist, exposed and developed in the same way as the inner layer resist, then chemically removes the copper that was covered by the plating resist. Finally, the tin is removed, which was protecting the copper image on the surface and in the via. This leaves the circuitry that is required and the copper in the via that is connecting all the inner layers to the surface. Now the outer layers are complete, we repeat the optical inspection process. Again, any faulty panels are discarded. The etched panels finally need to have the copper surface roughened, which is done chemically through the MEC etch line. Once the panels have been through the line, they are run through a Tech-Neck roller to remove any FOD. The entire panel is then coated in solder mask using either a spray or screen print process and dried in a tunnel oven. The panel is then imaged through a mask, black and clear, using UV light. Areas where the mask isn't required, solderable pads etc., are masked from the UV light. The Schmoll MDI machine can also be used to expose the solder mask. This is used when very fine apertures or tight alignment is required, generally for small BGA component footprints. The ident or notation is added to the board using a semi-automatic inkjet printing process. The text is applied over the solder mask, cured with a UV light, then inspected to ensure correct alignment and a crisp, legible image. Finally, the board is baked. A surface finish is applied to the exposed copper areas left by the solder mask process. This finish is used to protect the copper and aid the solderability properties of the finished PCB. All boards are inspected under magnification and run through the XRF machine to verify the thickness of the surface finish. This is a non-destructive test using a specific IPC coupon feature. The test is run to ensure all circuits meet our customers' requirements, industry specifications, and Merlin Circuit Technology standards. Electrical test uses a flying probe in order to check for open or short circuits. Every net is tested, and the results are automatically verified against the customer's supplied or generated netlist, thus ensuring the bare PCB is functioning as the customer requires. Merlin uses both horizontal and vertical test machines. The panels are now routed to a specific shape specified in the manufacturing data. The panel can either be scored or routed depending on the customer's requirements. The QA lab will perform various physical checks on the finished circuit board to ensure it meets the customer's specifications. The solderability of the board is checked to verify the board solders correctly, whatever the final finish. This is checked via a rotary solder dip method. Microsections are created using an automatic grinder and polisher. The section is ground to the centre of the required via. This allows the IPC trained engineer to inspect the internal of the board under high magnification for any manufacturing errors. The FAIR is generated at this stage from the results of the microsection and other tests within the QA lab. Panels that have impedance will be tested at this stage using a bespoke impedance coupon generated at the CAM stage and placed on each production panel. The operator will use the Polar CITS 880S TDR machine to verify the impedance. The boards are then visually inspected under magnification to check for the correct level of workmanship, as detailed in the customer specification. Finally, all the dimensions and via sizes are measured on the CMM, or the Coordinate Measuring Machine. The results are automatically added to the customer's FAIR, or First Article Inspection Report. The product is now packed in line with the customer's requirements in protective packaging and moisture barrier bags, along with a humidity card. The R&D department developed new processes in line with the needs of Merlin Technology Roadmap and fine-tune the current processes to ensure they are running effectively and efficiently. Thank you for watching. We hope you now have a greater understanding of the PCB production process. All footage was filmed at Merlin Circuit Technology in Deeside, North Wales. Find us at www.merlinpcbgroup.com.